6.4, rhombuses, rectangles, and squares. So we're going to have a pretty decent amount of examples in this section. So just be prepared for that. For any rectangle ABCD, decide whether the statement is always, sometimes, or never true. Draw a sketch and explain your answers. So number 12 says angle A is congruent to angle B. So we're doing this for a rectangle. So I'm going to draw one here. So it says their rectangle ABCD. And I know that what's true about the angles of a rectangle. They're all 90 degrees, so I'm going to put this in here. So, is this statement then always, sometimes, or never true?
Always.
Always. And then it says to like state the reason or explain your answer or whatever.
Because all sides.
Yep, all angles. I would say in a rectangle. And if you want to just do like the little symbol for rectangle, that's fine. You could say our 90 degrees or you could say our right angles. Either one would be fine. 14. AC is congruent to BD. So I'm going to just say C above for the picture. Okay. So AC, this is this diagonal and this diagonal. So are these things congruent? Is this always, sometimes, or never true?
Always.
Always. Anybody know the reason? Or remember what it is?
6.13.
What does that say?
Hyperboard.
If a parallelogram is a rectangle, if and only if its diagonals are congruent. So, diagonals of a rectangle are congruent. Now, obviously, you have your theorem and postulate book. If you wanted to say theorem 6.13, that's fine. I'm just writing it out, but if there's a theorem number, you can put that as well. All right, the next ones give us 4 pictures, so I'm going to draw them here for you. This is for 16 through 21. It says, list each quadrilateral for which the statement is true. So our options are parallelogram, I'm not going to write the names under these. I trust that you can figure out what these are. Rectangle. This is a rhombus. And then square. And you should be able to tell by their markings what they are. So they give us questions, and basically we're going to say out of the 4 shapes, which of them, and it could be multiple or whatever, fit this description. Okay, so 16 says it is equiangular. So what does that mean?
The second one?
Equiangular means the second one?
Rectangle and square.
Equiangular means rectangle.
Oh wait, equiangular. Oh wait, I'm slow. Hang on. Equiangular means all but angles are the same. I'm actually.
All the angles are congruent. So which of the shapes now
The second one.
meet that?
The rectangle and the square.
Okay, the rectangle and the square. English is hard.
Yeah, I saw on TikTok today, it was like, I wish MLK had 2 dreams because I'm not really feeling Tuesday either.
All right, the diagonals are perpendicular. So which of these have diagonals that are perpendicular?
Rhombus.
Get off.
What other shape is also a rhombus?
The parallelogram.
No,
Oh wait, a square.
a square.
I'm actually really slow.
Okay, a parallelogram could be a rhombus, but it doesn't have to be. Okay, if it doesn't have 4 congruent sides, it can't be. So, rhombus and then a square. A square is always a rhombus.
There's no proofs, right? Or it's gonna be
Well, there are, but we're not doing them. Because in a sense, you are doing it with stuff like 12 and 14. Like, you're giving the reason. It's just a 1 step instead of a, 5-step proof type thing.
Yeah.
20. The diagonals bisect each other.
Square.
That's one.
Right. No.
A rhombus.
Rhombus is one.
Is all of them.
It is all of them. Rectangle and parallelogram.
Can we just like draw like a square?
As long as I can tell what your shape is, just make sure, like, if you're doing a rhombus, like, give it a little slant.
For parallelogram is just like slanted rectangle.
Yeah.
I should probably be on those.
The way the book does it kind of cracks me up. When they write their answers, they write the word out for these 3, and then for parallelogram, they do this. I'm like, I don't really know what that's saving you, but okay. But just make sure it's obvious. Like, if it's a square, I mean, I'm not going to get a ruler out and measure it, but, make your rectangles kind of, like, obnoxiously, like, sized so that I can tell. And
It's
then
not a
with, like,
square.
your square, get it as close to, like, all the congruent sides as possible so that I can tell. Make your rhombus and your parallelogram a little slanted so it's obvious. But that's fine.
What if we put, if there's rhombus and parallelogram in the same insert, so we put just parallelogram for both?
Well, you have to have rhombus as well. They're 2
Yo, we're
different
doing
things.
bad. Only have 2.
I forgot I also need to add 2 for pre-cal from earlier.
Can you make a couple mistakes, please?
Sometimes I do, y'all just don't catch them. All right, sketch the quadrilateral and list everything you know about it. 22. Parallelogram. FGHI. So they want us to sketch a parallelogram, and then they want us to tell everything that we know to be true about it as well. Okay? So, I'm going to draw my parallelogram. I'm going to put my letters on here. All right, so I personally like to kind of like mark up the shape first, and then this is a really bad parallelogram. I'm going to redo it.
It just has to be one slanted side or both of them?
They're all like slanted. It's like you took a rectangle and you went. It's like you slanted just the top of it over, and then it just. Boop. All right, so I like to mark up the shape first before I start trying to write out in letters everything that's happening. So what do I know to be true about, let's say, the sides of a parallelogram?
Longer sides are parallel, and then the shorter sides.
So I know that the longer sides are parallel and the shorter sides are parallel to each other. What else do I know about the sides? Opposite sides are congruent, so this is congruent to this, and this is congruent to this. What do I know about the angles of a
They're
parallelogram?
90 degrees. They're equal. Congruent.
What's congruent?
Opposite.
Angles.
opposite angles are congruent.
FH.
Yep. Opposite angles are congruent, so FH, those are congruent, and then GI, those are, or angles, G and I are congruent. And then, do I know anything else about parallelograms?
No.
Their diagonals bisect each other. I don't question where I got that
Yep.
from.
I'm not gonna put anything with that on here, but I am gonna make a note of that the
It'd just be like an X along each other.
FH, yeah, it would just be going through opposite. FH and GI, okay, those are my diagonals, bisect each other. And then I just need to basically write down the stuff that I have marked off on here. So, let's do this. FG is parallel to HI, and GH is parallel to FI. And then do the same thing with the congruent parts. FG is congruent to HI, and GH is congruent to FI. I don't know why I'm forgetting to put the lines on like the top of the second ones.
I was gonna say, we don't have to put it on.
I don't know why. I think it's because when I like crossed like the I just thought that was like the cross the top. All right, and then the only other thing I haven't basically written in words or in symbols yet is that angle F is congruent to angle H, and angle G is congruent to angle I. And that should account for everything there. So you'll just basically, on the ones that you have to write the stuff about them, you'll just need to write down everything that you know to be, like, true about those things, okay? Any questions so far? Okay. 28. Next page. For any rhombus, A, B, C, D, I'm going to write this up here so I know what shape I'm dealing with. Decide whether the statement is always, sometimes, or never true. So the first ones we did that for were rectangles. Apparently I can't spell rhombus. E-U-S. There we go. Draw a sketch to explain your answer. So, and explain your answer. 28. Angle A is congruent to angle B. So, I have my rhombus, A, B, C, D. So, is this that A is congruent to B always, sometimes, or never true?
Never true.
You sure?
Never.
Yeah, we just confirmed that.
So, if you say sometimes, in which situation would it be true?
If it was a square.
That one.
Yep.
Rectangle.
Sometimes, if it is also a rectangle, right? Because rectangles, all the sides are, or all the angles are congruent, right? Slash square, or, you know, whatever, square. Then all four angles are congruent. All right, still looking at a rhombus. 30. AB is congruent to BC. It's always, sometimes, or never true. Always. Why?
Because they're all congruent to each other.
Yep. All the sides of a rhombus are congruent. I just used the picture above again.
What
A rhombus, all four sides are congruent. A parallelogram, just opposite sides have to be congruent. So a parallelogram could be a rhombus. Or, yeah, could be a rhombus, but it doesn't have to be.
I thought it was the other way around.
A rhombus is always a parallelogram. A parallelogram is not always a rhombus.
Cooked.
All right, find the value of x. 34. EFGH is a rhombus. And then they give us a picture of it. And they tell us angle F is 130, angle G is X.
That's what a rhombus looks like.
Well, it's basically a slanted square. But, yes, basically. Kind of looks like a diamond. I don't know. They kind of are all the same thing. All right, so I need to solve for this. So what do I know about if I have angles that are side by side?
They're parallel.
Angles can't be parallel. Starts with an S.
Supplementary.
Supplementary. So that means 130 plus x is equal to 180.
So x equals 50.
So x is equal to 50. So that would be the answer for that one. $36. PQRS is a parallelogram. And they give us and it has the diagonals drawn in for you. And then they tell us that this piece is 2x and this piece is 10. And I'm solving for x. So what has to be true about those pieces there? That they,
X equals 10.
yep, because it bisects, so that means that those two pieces have to be equal to each other. So 2x equals 10. So x equals 5. $38. CDEF is a rectangle. And they give us this side is 8x minus 13, and this one is 7x plus 11. So what do I know to be true about this?
The sides, they're equal to each other?
Yep, they're going to be equal to each other. So 8x minus 13 equals 7x plus 11. So we're going to subtract 7x. And I'm going to go ahead and add 13 at the same time. So these 13s cancel, these 7x's cancel. 8x minus 7x is x. 11 plus 13 is 24, so x equals 24. Questions about those ones? All right, 39 through 42. GHJK is a square. And the diagonals intersect at L. And then they give us a picture. And then they give us a few of the values here. So this is 2, and then this is the square root of 2. And then we're using this information to solve for the different pieces or things that they ask us for. So number 40 says HK is equal to blank. So HK is this diagonal right here. Okay, so what do I know to be true about the diagonals of a square?
It's 39.
They all are equal to each other. Or congruent to each other.
It's fine. We'll do it anyways. Thank you. This is actually problem 39. It's fine. Yes, the diagonals are congruent. Okay, so if I know that GL is root 2, what does that mean about LJ?
It's also a root of 2.
It's also root 2. And then I know that if I add those two things together, they are equal to HK. So in case you need a refresher, to add the square root of 2 plus the square root of 2, these are like terms, okay? And so this would be equal to 2 square root of 2. Okay, it is not equal to the square root of 4. It's equal to 2 root 2. See if I can read the correct question this time. 42. The perimeter of triangle HJK is equal to blank. So HJK is this big triangle right here. Okay, and I need the perimeter of it. So what do I know about this? What is side HJ equal to?
2.
What is side JK equal to?
2.
And then we know that this whole diagonal here is 2 root 2 because we already found that up here. So this is 2 plus 2 plus 2 root 2. We can't add these all together. I can only add these first twos. They're like terms. And so this would be 4 plus 2 root 2. Questions about that? Okay. Okay, the next ones are going to require some graphing, okay? So you don't need like graph paper or anything, but it's going to require us to set these up so that we can figure out what's the situation. So they tell us that PQRS is a parallelogram. We're going to graph the parallelogram, and then we're going to use the information to decide if it's a rectangle, a rhombus, a square, or none of the above. Okay, and we're going to use theorems and stuff to help us figure that out. So, 56, P is the 0.52, Q is the 0.19, R is the -0.32, and S is the 0.1-5. So I need to see where these fall on the graph so that I can answer all the questions that I need to. So I'm going to go ahead and set up a graph here. It looks like other than on the positive y-axis, I only really need to go out to 5, so. All right, so I'm going to plot each of these points. So remember, these points are x then y. So 5, 2 would be over to 5, up 2. That's exciting. Okay, maybe we won't die now. Or lose my book. Okay. So there's point P. Then Q is 1, 9, so right 1, up 9. R is negative 3, 2, so that's left 3, up 2. And then S is 1, negative 5. So that's S. Now, obviously, if I was doing this on graph paper, it would probably be a little bit easier to see. Okay? Kind of looks like a diamond on here. So, I have a couple of options as far as, like, what to do with this. Now, you may notice a lot of times I want to look at the diagonals to help me figure these kinds of problems out as far as what's going on. So, I'm going to look at basically this going this way. And then this one going this way, okay? So, I need to look at the slope of SQ and PR, okay? So, the slope of, I don't know why I did PR first. So, this is y2 minus y1, so that's 2 minus 2 over x2 minus x1, negative 3 minus 5 is 0 over negative 8. Well, what's 0 divided by negative 8? 0. And then I'm going to do the other slope. So the slope of SQ, negative 5 minus 9 over 1 minus 1. So that's negative 14 over 0. Well, what's negative 14 over 0? No. Undefined. So if one of the slopes is 0 and one of them is undefined, okay, these are for the diagonals, that means that they are perpendicular. Okay, so this means that these are perpendicular. So the diagonals are perpendicular. So it is a what? Rhombus. And that answers what we were trying to find. All right, 58 is our last one. I know this is long. P is the 0.52, Q is the 0.25, R is the point negative 1, 2, and S is the 0.2, negative 1. Okay. So I need to plot these points. Looks like I can go out to 5 in all directions and be good to go. So all right. So P is 5, 2, so that's right 5, up 2. Q is 2, 5, right 2, up 5. R is negative 1, 2, left 1, up 2. And then S is 2, -1, so that's right 2, down 1. So, what does this kind of look like it might be? Looks like it might be a square. So first I'm going to check to see if the diagonals are perpendicular, because then just like the previous one, that would at least tell me that it's a rhombus. So, the slope of PR, same way we did the last one, so 2 minus 2 over -1 minus 5. So that's 0 over -6, which is 0. The slope of SQ, -1 minus 5 over 2 minus 2. -6 over 0, which is undefined. So, the diagonals are perpendicular, so it is a rhombus, first of all. But a rhombus can also be other things, and this one kind of looks like a square to me, right? Or at least maybe a rectangle. This one didn't really look like that, so I didn't really do anything else as far as that goes, so that's why we didn't do that. But on this one, I can tell you that there is going to be more. If you're not sure with like the previous one, you should check the like side links and stuff like that. Now, I just realized I did not put letters on here. What letters are these? This was R and this was S. Yeah. So, after looking at the diagonals and showing that they're perpendicular, the next thing that I'm going to do is I'm going to look and see, are they congruent or not? And I can go back on the last one and we can look at this too, but it won't really matter for that one. But if you notice, the y value of R and P are both the exact same thing, right? So I can actually just figure out the distance that it is from R to P. So R was at -1 and P is at 5. So what is the distance from R to P? From -1 to 5. Just count. 6. So PR is equal to 6. Now I'm going to do the same thing with QS. Okay. So they have the same X value. They both are 2. So I'm going from -1 to 5. So what's the distance of QS?
6.
It is also 6. So, since those are both equal, the diagonals are congruent as well. So what other thing would I be able to say about this shape? Well, it's a rectangle, technically. Well, I'm just trying to figure out what shape it is. Diagonals are congruent, so it's a rectangle. But then I have the thing called the square corollary. I'm not going to write the whole thing out, but it says that a quadrilateral that is a rhombus and a rectangle is a square. So that means that this is a square. Okay, you could have also, another method you could have used is you could have found the distance between R and Q, Q and P, and you could have found the distance there and showed that the sides were congruent as well, if you wanted to. If I went back and did the same thing that I did, distance formula here, actually I wouldn't have been able to do that with this one because I would have had to use the distance formula. But for the sake of time, I'm not going to do that, but I could have used the distance formula to see if those were congruent. They're not. That one's just a rhombus, but anyways, questions about that? I know this is a lot. Okay. The focus really needs to be, you're going to have questions on your quiz, looking at the quiz review, that's what I just popped over to look at, but that are going to give you points. And you're going to have to use your knowledge about the different shapes to determine what basically shape those points make. Okay? And we're going to have other shapes, trapezoids and kites, I don't remember if that's it or not, that are going to come into play as well. So this is where I would say, you know, obviously you need to understand it all, but this would be where your focus really needs to be, is in being able to determine what kind of shape it is from coordinates, okay? So problems 13 through 23 odd. 27 through 41 odd. I obviously did 39. You can just skip that one. And then 55 and 57. You need to copy, like, the questions out, obviously. Like, you know, where was it? I was like, did I
What was
lose
the
the
last
whole
two?
thing? I'll go back in just a second. You need to copy the question like I did here in 42, but if there's a picture, you don't have to copy the picture, okay? Because I know this is long, so I don't, you know, I don't want you to take up all your time. So those are your problems. And like I said, we did 39, so you can kind of like skip that one. Obviously, we already did it, but